so offended right now. I don't think I could even handle my anger.
This is not bigger than a toaster.
Okay, here we go. Hey, let's go. Okay, so in last unit, you learned how to calculate an integral using your calculator. You would just plug it in and find the result. This is preparing for the 80% of the AP test for which you can't use a calculator. 1/3 of the test is calculator allowed, but only about 20% of the questions actually require a calculator. So anyway, we're going to do this without a calculator today. Where we start is with the fundamental theorem of calculus. So think of this as f prime. We talked about that last time. Think of that as f prime. According to the fundamental theorem of calculus, this integral must equal the difference in the two f values that are expressed as limits. So this is from Unit 4. The fundamental theorem says that's true, that the integral of f prime is equal to the difference or change in two f values. So this formula that I've written on the board is not new. We're just applying this formula to an actual integral. What you've seen before is this formula, the integral from a to b of f prime dx is equal to f of b subtract f of a. So we're just using that with this specific formula representing f prime. Okay, don't want to go forward until that feels really good, so any thoughts about that that's bothering you?
So are we just going to take the antiderivative of that equation?
No, it's perfect. That's why we did the buff sheet in preparation for the pink one, is we now want to find the antiderivative of this formula, because the antiderivative of that formula will be the formula f. That's what we're trying to do. 2 points. Questions? Please, John.
So in your green formula there, you said it's minus f of a, but when we did the problems, like if f of 0, it could be f of 0, right, if it goes from 0 to b, don't we usually add, though, that initial amount whenever
What you're remembering, 2 points for Jonathan, is a rearranged version of the fundamental theorem. So you're remembering when we would do this, we'd say we want to find f of b, so we would take f of b must equal, we add this to the other side, and you end up with f of a plus the integral. Is that what you were thinking?
Yeah.
Does that answer your question? 2 points. Look at that pink right here, right? For the yellow. Okay, so where we want to head is we want to think we're doing the buff sheet first. We're going to use what we learned from the buff sheet to find the antiderivative of this formula. We will think of that formula as being f prime. That will give us a formula for f. So that's where we'll start. So I'm going to erase some so we can get some more space here. Questions? Cool. Okay, first step is simply memorized. When dealing with a square root, I've always found it, well, not always, but most of the time better to change it to 1/2 power and also get it out of the denominator. That doesn't seem to help. So I'm going to take that above and rewrite it like this. Don't forget to write the limits. Questions? So I changed the square root to 1/2 power and then moved it to the numerator. Okay. So I've got to find the antiderivative of this. I don't have a formula, so U substitution is my best choice. Let's pay points to the whole room. Raise your hand if you have an idea of what I should select as U. There we go. Let's wait for a few more. Points for trying. I don't care if you're wrong or right, so just know your hands ready. Isaac?
Is it the 1 minus x squared negative 1 half?
Close. 3 points for Isaac. So I have to start my U substitution thinking by identifying two functions that are multiplying. So I'm going to think of these two functions that are multiplying. In fact, I might even pull out the 2 just to make things a little easier to see. So I have the blue multiplying function, and I have the red multiplying function. The blue is of the form something to a number. So the blue is something to a number. The red is also something to a number. I always select U as the something. So one possible selection for U would be just X. The other selection for U would be just 1 subtract X squared. Okay? So just checking, raise your hand if you knew that was a choice for U, 1 minus X squared. 2 points. I never want to pick U in place of X, so I would never write this down. I would never write U equals X, because that's not going to make any difference. It's just a letter change. It doesn't change anything. So that's not a good selection for U. Therefore, the other selection appears to be the only logical choice. U is equal to 1 minus X squared. Questions? Okay. So now I take the derivative. So I differentiate both sides of this equation with respect to X. Just pay points. Raise your hand if you know what goes on the right half of that equation. Don't overthink it. What goes on the right half? What belongs right here? Nelson?
2x.
The negative, but yes. So negative 2x. How many knew it? 2 points. 3 for Nelson. Okay. What we talked about last time is, or last time we did U substitution, this expression needs to be an exact match for this expression, other than the multiplying constants can be different. So this multiplying constant is 1. The multiplying constant over here is negative 2. Otherwise, it's a perfect match. That's what I want for U substitution to work. Therefore, I know this is the correct choice for U. So, questions? Okay, so now I make my substitutions. Oh, we've got to do something new. When we did the buff sheet, there were no limits. Now there are. These limits are values of X. We are trying to do a U transformation. We're changing from values that use X to values that use U. So we have to change the limits as well. It says right here that every U value is simply 1 subtract the X value squared. So you just use that formula. You write down, let's see, X is 1/2, so let's go U. It's down on that side of the board, it never works. So U is equal to 1 subtract, you always replace a variable with parentheses when substituting. So 1/2 squared like that. So we're simply using this formula right here to calculate a value for U. So 1/2 squared is 1/4. Therefore, what we have learned is that when the x value is equal to 1/2, the corresponding u value will be 3/4. Again, we're doing a u transformation. They call it u substitution. I like the word transformation. We're changing everything from u to x to u.
How would that work on the bottom limit though?
So same thing, we just plug it in. So we write u equals 1 subtract the x value, which is 0 squared. So that limit is 1.
So it'd go from 1 to 3/4?
So now the limits seem like they're backwards because we're going from higher to lower. But weird, but we have to go with it because that's the equivalence.
Okay.
Yeah, 2 points. There you go. Okay, summarizing again. We started this unit with the idea that if you see this with no limits, that means we're supposed to be finding an antiderivative. And we practiced that on the buff sheet. And on the buff sheet, we practiced using a u substitution. On the buff sheet, we didn't have to do this because there were no limits. Now what we're doing is basically still the buff sheet. We're still trying to find the antiderivative of this. But because there are limits, we have an extra step. We've got to see how the limits change as well. Questions? Cool. Okay, now we can make a lot of substitutions because we can say this is going to equal, there's the 2. As Eric said, the limits go from 1 to 3/4. This x I'm not doing anything with yet. I'm going to make a substitution here. This will become u to the negative 1/2 multiplied by x dx. Questions about anything? Awesome. So now, just like the buff sheet, we're going to use this to make a replacement for this. So, get some room here. Normally I would want you to just keep going down the page, but ran out of page, so we'll go here. So I multiply both sides by dx, multiply both sides by negative 1/2. I get negative 1/2 du. It's the same thing as x dx. So this x dx is a pink box, which according to my algebra would be equivalent to this green box. So I simply remove the pink box here, take away this pink box, and in place of the pink box, I substitute the green box up here. So I get a brand new integral that looks like this. 2 multiplied by the integral from 1 to 3/4 u to the 1/2, negative 1/2, multiplied by negative 1/2 du. Questions about anything? Please.
Sorry, Bob, how did you get that pink box up to the green box? How did you do that process?
So are you comfortable here? Is that okay there? All I did is I said this symbol means du divided by dx. Are you okay with that idea? So that means that it's legal to multiply this half by dx, which would simply give me a du. Good with that? But if I multiply this half by dx, I have to multiply this half by dx. So I would get x times dx. Then what I did is I multiplied this half by negative 1/2, because negative 1/2 times negative 2 would be 1. That's the 1 right here. That means I have to multiply this half. That's where that came from. If I explained that, though. Good? That's 3 points. Please, Logan.
So let's say you didn't take out the 2. Could you just move the negative to the other side? So it'd be negative du equals 2x dx?
Yes, that would be just as legal, for sure. Just a different approach, just as good. Easily just as good. Does that make sense? 3 points. Anybody else? Cool. Okay, we have completed the U transformation. We're trying to do this problem, but because we don't have a rule for finding this antiderivative, we have to do a U transformation first so that we can have a rule for finding the antiderivative. So we have a brand new problem right here, and we're never going back to here. That's one difference. When you're just finding an antiderivative, the final step is to always go back and substitute your choice for U into your result. With an integral, you don't go back. You change everything to U and stay with U. Questions? Cool. So, let me copy this over. We'll keep going. Wrong thing. There we go. Okay, so the problem we're solving now looks like this. We have 2 times the integral from 1 to 3/4 of U to the negative 1/2 multiplied by negative 1/2 du. This is a multiplying constant, so it can come out. When it multiplies by the 2, you'll get negative 1. Question? Okay, so you really want to divide your brain into kind of 2 segments for this problem. The first half is thinking U substitution. That's what we did here. We did that U transformation. So here, we did the U transformation. That's the first half of the problem. Now you can start fresh and say, okay, I have an integral. I can't use my calculator, but I can think of this as being f prime. And I need to find f. So now I have a rule that allows me to find f. So this is going to equal negative 1. The formula for f will simply be U raised to the negative 1/2 plus 1 divided by the same thing. That's my formula for f. But remember the fundamental theorem, which said the integral from a to b of f prime is going to equal f with b plugged in, subtract f with a plugged in. Come on. There. Come on. Sometimes. Please. So I'm thinking of this as being my f right here. This is my f. I need to plug into that f values of B and values of A. In other words, I need to plug in this value and this value. So there's some notation that kind of helps this work go a little smoother. Another way to write the fundamental theorem is like this. So this notation is new. I don't believe you've ever seen this before. F of x, bar, A to B. This means the exact same thing as this. It's just a little more convenient for certain work. Question? Please.
So how would you just go from the negative 1/2 to the negative 1/2 plus 1/2?
So what I did there is I used on your green sheet the power rule, which says this: the antiderivative of, I'll use u in this case, u to any power is simply u to that same power plus 1 divided by that same power plus 1. You see that? First rule. So what I'm doing is I'm actually using two thoughts here. One thought is I'm remembering that any integral, if this is f prime here, the f prime of u, then per the fundamental theorem, this integral has to equal f of 3/4 subtract f of 1. So I'm making two thoughts simultaneously. I know I'm trying to get to here, which means I'm trying to take this f formula and use, f prime formula, and use it to find a formula for f. It means I'm trying to find the antiderivative, because f is the antiderivative of f prime. This rule says the antiderivative of this f prime is this f. I don't know if I answered your question, though. 3 points. There you go. So I found a formula for f. It's right here. If I'm thinking of this blue as being f prime, then this is f. And I need to plug into f my limits of 1 and 3/4. So that's why I draw the bar. Questions about anything? You don't need to repeat anything. Do it again. Back up as far back as you want me to back up. Offer you a Kleenex. Please.
When I've seen the bar in like other problems, they say like x is equal to it. Why do you not have to put the variable is equal to?
I'll pay a ticket for that one. You are correct, Jonathan. In our previous uses, we've done things like this. We've said, let's go find the derivative of, I don't know, x cubed or something. And let's do it at an x value of 5. So that's the notation you've seen.
Yeah.
And that is correct notation. And the only answer I have for why they don't do it here is whoever invented the notation just elected not to. Yeah, I don't know that there's a specific reason why they put an x equal here and they don't just put a 5. Because it seems like maybe that would be logical to just put a 5 there. They don't. You have to write x equal. Here you don't have to. So the question is perfect. There's not a better answer. Somebody else? Awesome. So remember what the notation means. This notation means we are to take this formula, which we're thinking of as being f, and we are to plug into that formula the upper limit and the lower limit and find the difference between those two f values. That's what we're trying to do. Questions? So now we do it. So copy this over. clear this one off. Here we are. We've got no more integral sign now. We just have u. Let's see, what was that? It was -1 times. Yep. So we have -1 multiplied by u raised to the, this will become u to the positive 1/2 divided by 1/2. We're supposed to find it from 1 to 3/4. It's another reminder that good notation here will save you. Like, you should be going just straight down the page, equal, equal, equal. This is divided by 1/2. Dividing by 1/2 is the same as multiplying by 2. So I prefer to write this as -2, parenthesis, u to the 1/2 means root u. Three-fourths and 1. You do not have to write every line. If you can do things in your head, that's fine. Just make sure your notation makes sense. Questions? It's another example of, if you don't follow my notation, you invent your own, I won't help you. It's way too hard to follow if you're trying to be creative. Just follow this notation. Edward, please.
Oh, was that just it? Was that the final answer?
No, because we still can do some calculus. They want you to plug those values in. So we say, this is my formula for f now. And for the fundamental theorem, I'm supposed to plug in this value and then this value and subtract. So this becomes -2 square root 3/4 minus -2 square root of 1. If it were the written portion of the test, I would now stop. Just, there's nothing left but basically arithmetic, and I'm not required to keep going on the written portion. Because it's multiple choice, I've got to keep going to find one of the answers that are listed above. So, question. Cool. So, let's see. I remember that the square root of a fraction is the same thing as the square root of the numerator divided by the square root of the denominator. Like that. Negative negative makes positive. Root 1 is just 1. Root 4 is 2. 2 divided by 2 would be 1. So now I have basically negative root 3 plus 1, no, plus 2. So the answer is E. If you want to talk about any of the math, please.
I know this question is creative, but why do you want to take the impact of derivative of that integral when it's just an integral? Why don't you want to just like solve it? Why don't you take it?
So, hold on. Okay, I want to answer Matt's question, but I want all of you participating in the answer, so I'm going to give away extra credit for this. The goal of the problem is to find the value of this integral. We spent Unit 4 learning and practicing that one method of doing that is to simply take every value of x from 0 to 1/2, plug each of those values into this formula, multiply by a tiny value, do it over and over again, and add them all up. And your calculator does that really well and really quickly. So if you pick up your calculator and you type in this, you're going to get this result. The calculator won't say 2 minus root 3. It will give a decimal. It will give a decimal value that is the same. You're okay with that?
So,
Go ahead.
what we just did is just doing it without the calculator.
Perfect. Yeah, if it's the calculator section, there's no reason to do what I did. It's just that for the AP test, 80% of what they're testing on is no calculator, so they expect you to know how to do it without. Why? That is a much harder question to answer. Anybody else? Please.
Do you mind going back to the
Uh-huh. Matt, I don't know if that answered your question.
No, yeah.
Okay. Go ahead, David.
how did you get from -2 times the square root of u down to -2 times, or wait, no, sorry, from the one above to that?
Here?
That to there, yeah.
Here to here.
Yes.
That is your name, right? It's really small. Yeah. First thing, are you okay, David, that dividing 1/2 is exactly the same as multiplying by 2?
Yes.
So what I have here is I have 3 factors. They're all multipliers. -1, 2, and u to the 1/2. And so I simply took 2 of those factors, multiplied them together. The 2 multiplied by the -1 would give me -2. And then I'm left with u to the 1/2, which is the same thing as square root of u.
Yeah.
Is that your question?
Yeah.
2 points. Anybody else? Okay, let's do another example. And on the on Canvas for the pink, I have about 8 videos posted of different examples I did last year, so you can utilize those as they're to help you with the homework as well. Let's go here. So number 2, actually this is what number 1 looks like. Number 1 is awfully similar to number 4. The limits are different, but if you follow the process for number 4, as you're working number 1, you should be just fine. So we'll do number 2 instead. Okay, number 2 says, what is the average value of 3t cubed minus t squared over that interval? So the first thing you have to do is remember from unit 4 that to find the average of a function, you are going to want to integrate the function over the interval of interest. Don't forget your parenthesis here. And don't forget that to find an average, we not only must integrate, we must also multiply by the difference between the 2 limits. So 3 subtract -1 is 3. So this integral covers a span of 3. Therefore, we must multiply by 1 over 3. Questions? Okay, so all I've done so far is remember unit 4. And 2 points for math. If this were the calculator section, I would simply pick up my calculator, type it in, done. Read the name for me.
Carter.
Thank you. Because I can't use my calculator, what I want to do is I want to think of this. So I want to think of the fundamental theorem, which says the integral from -1 to 3 of f prime is the same thing as f evaluated at the 2 limits. That's a 2, thank you. We'll fix that in a second. Okay, this is the fundamental theorem of calculus. Questions? So I'm thinking of this as being my f prime, and I want to go find out. Thinking of that as f prime, I want to go find out. Once I find f, I can plug in the limits. Well, this one's a lot easier because I'm subtracting, so I can search for the antiderivative of this separate from the antiderivative of this. So next line, make sure your notation is very clean here. 1/3, parentheses. I'm not going to have the integral sign anymore because I'm going to find the antiderivative. The 3 is a multiplying constant. I just write it down. The antiderivative of t cubed is t to the 4th over 4. The antiderivative of t squared is t cubed over 3. So this is my f. That's why I no longer have the integral sign, because I have found f primes. If I start with f prime, I found f. And according to the fundamental theorem, I don't have an integral sign on this side of the equation. I've gone from f prime to f. So I've gone from integrating f prime to simply evaluating f. So the big S means integrate, the bar means evaluate. Questions about anything? Does it need to repeat anything? Please.
So wouldn't you put the bar at the end of that second bottom equation?
Wish I could say I did that on purpose, but I cannot. The timing was perfect. Question? Awesome. So now all that's left to do is plug it in. So you just plug it in. We say 1/3. 3. Plug in a 2 to the 4th power. Divide by 4. Subtract. Plug in -1 to the 3rd power. You notice, because the -1/3 is a multiplying constant to f, I can just leave that as a multiplying constant and simply apply. Okay, I made a big mistake here, though. Hold on. No one spoke up quick enough to get the ticket, but this should have been minus. I'm still plugging in the 2. Sorry about that. And now I subtract it all again. These are the kind of problems I do not like to get on the multiple choice section, but I'm perfectly happy getting them on the written section because I can stop right now. If that's the written section, I just stop right there, and I'll get full credit. Nelson, please.
Well, you lost 3 on the second equation.
Ah, shoot. Here, yes?
Yeah.
Hold on. Please.
So why did you double the 1/3 again when aren't we doing all this work and then at the end we'll just multiply by 1/3?
Now that's what I was trying to say before I got caught up in my mistake. So it is true that you can do that either way. This is one big term which has a factor of 1/3. This is another big term that also has a factor of 1/3. So yes, the 1/3 can just be factored out. Either way. Okay, I can't stop here on the multiple choice though, so I have to keep going. So so we get 1/3. We'll try it that way. We can pull out the 1/3. Oh boy, 2 to the 4th is 16. 16 divided by 4 would be 4. 4 times 3 is 12. Question. 2 cubed is 8, so that's 8/3. Negative 1 to the 4th would be positive 1. So that's positive 3/4. There's a negative, so it's negative 3/4. Negative 3 cubed is negative 1. Another negative makes it positive 1. Another negative makes it negative again, so that's negative 1/3.
But then you're subtracting it normally, right? So it should become positive?
So this would be negative 1 cubed is negative 1. So this would be negative 1/3. When you distribute, the negative becomes positive 1/3.
Oh, we're distributing that one. Cool.
Yeah, this one has to distribute because of the parentheses. Makes sense, Nelson?
Yep.
2 points. This becomes negative 1/3. Something you'll notice in a lot of problems, these two terms often combine easily, and these two terms often combine more easily. So I always look at those. So 12 minus 3/4 is 11 and 1/4. Yuck. No, 10 and 1/4. No, 11. Come on, brain. That's going to be 3 because it's 9/3. So 11 and 1/4. Yuck. 44, 45/4. 3 is the same thing as 12/4. Questions? Welcome to 6th grade. So 45 minus 12 is 33. So you got 1/3 multiplied by 33 over 4. So of course the dirty rats that are the AP test writers, there's the trap. Don't forget you have to multiply by 1/3. There's the answer. You don't want me to do anything again. Cool. Next one. This problem is review from the buff, so I won't do that one in class. There's no video for that either because it's just review from the buff sheet. So we'll skip that. You've done number 4. Number 5, I'll leave that one for homework. 6, homework. Let's do 7. 7 says the average value of f on that closed interval. So we start the same way as we did number 2. We want to integrate whatever we're averaging. We're going to replace the square root with a 1/2 power. We're integrating from 0 to 2, therefore we must multiply by 1 divided by 2. Question. Trying to give part of the thumbs up. There we go. Please.
Why did you replace the square root with the 1/2?
I'll pay you for that one. That is just pure experience. Like I've just learned when I'm finding antiderivatives that I can't deal with the root very productively. Once I make it a power, now I know I have that power rule of the antiderivative. Does that make sense? Yeah, why not? So, okay, I want kind of a silly game, but I want to see how many people can read my mind. As I look at that, I am thinking of this as representing something. Raise your hand if you think you know what I am thinking, I'll pay you. I'm thinking of that green formula as representing something. What am I thinking of it representing? I'm going to use a U substitution for sure. Before I do that, I'm thinking this is an integral. I can't use my calculator, so I want to think of this as representing what, Brinley?
Like f prime of x?
Perfect. It doesn't mean that it technically is f prime of x, but who cares? It's just so I can think about the problem. How many thought what I was thinking? 2.3 for Brinley. Because that's reminding me of the fundamental theorem. I'm going to write that down over here. Raise your hands if you can tell me what I'm going to write. I'm going to write the fundamental theorem. What do I write? Okay, everybody? Don't take points if your hand isn't ready. Allison?
Or 1/2. The integral is 0 to 2. But f prime of x dx is equal to the bar.
Close. You do the f first.
Oh yeah, okay.
No worries. It's kind of weird. Plus the board don't work. Come on, board.
Is it f of x or is it just f?
It's f. The board is going here. Come on. Sadness. There we go.
Oh, 0.
Yeah. So
Is that an average value?
the way I like to say it is the integral of f prime is equal to f, or like we integrate f prime and we evaluate f. They're the same thing. Integrating f prime is the same as evaluating f. How many knew that? Hands up. Come on. 2.3 for Allison. Questions? So that's where you've got to be thinking. So your first goal is to find f. And in this case, I'm going to have to do a U substitution to do that. So this problem is going to break into two pieces. One, do the U transformation first, create a brand new problem, and then we'll go from there. So let's get you to think how I'm thinking. Who knows what I'm going to use as my value of U? Hands? What are we going to use, Cambria? How many knew it? 2.3 for Cambria. So I take the derivative, the U dx. That works perfectly because over there I have 3x squared. Here I have 1x squared. I don't care that the multiplying constants are different. All I care is that x squared matches x squared. Questions? Please, Mike.
How do you know that you live in
Gotcha. So what I always do, oh sorry, you said more, I cut you off. Say it again, Mike.
well, just like, cause I feel like couldn't it be like x squared
You're close. Let's see if this helps. To do a U substitution, you first must think of having two functions that multiply. So the first one is right here, and it's of the form something, that's something being x, to a number, that number being 2. The other multiplying function in blue is also of the form something to a number, but the something in that case is x cubed plus 1, and the number is 1/2. You okay there? Hold on a second, Eric. The choice of U is always the something. So in the red case, my selection for U would just be x, which I know is a dead end because it's never going to help to just swap letters. So I only have one logical choice, the other something, which is x cubed plus 1. Does that help at all? Yeah. 3 points there.
Have you ever encountered a problem like the test, the two terms for the U substitution when you
Could be what?
take either term? You take either term for U substitution?
Oh, gotcha. I don't recall any like that. Doesn't mean there hasn't been one. I'm just not thinking of one, so I don't think it's very common. Yeah, I don't know for sure if there ever has been one. There will be cases where U substitution won't work at all, and I'll have to show you some other tricks which we haven't really encountered yet, so I'll show you that in the future. Cool? So that looks good. So I rearrange. Start doing I've got to make my choices for U now. So I've got to change U. So U equals the x value, which is 2, cubed, plus 1. That's 9. The lower limit is U equals 0 cubed, plus 1, which is 1. So we need me to talk more about how to change the limits. So now we start changing everything. This is going to become 1/2. The new limits go from U equals 1 to U equals 9. We have U to the 1/2 power. And we have x times dx. This is no man's land. We can't have an integral that uses x and u. Logan, please.
Isn't it x squared dx?
So I replaced this with u. And this one goes like this. How many saw that mistake? 2 points, 3 for Logan. Please, Jack.
When we're finding the u values of the limits, do we have to put like u of 2 or something for notation wise, or is that fine?
Oh, that's awesome. They're actually fine with the way I'm doing it. If you did it the other way, that would be fine as well. Either way, it's very good. Anybody else? To be honest, Jackson, I don't think they're going to check here at all. They'll just assume this is kind of scratch work and it can be pretty messy. They'll just make sure you have the right limits here.
Shouldn't you have 3 before the u to the 1/2, like to the power of 1?
3 here?
Yeah, because you had 3 in the.
Oh, I haven't done anything with this yet.
Oh.
Is that okay?
Yeah.
What I want to do here, 2 more for David. I rearrange like I often do. I'm going to move the 3 over. I'm going to move the dx over. So now what I do is I replace the x squared dx, this red box right here, that gets replaced with this green box. Is that what you're referring to, David?
I was thinking that when you replace the x cubed plus 1, you replace that with. Oh, you just replaced the whole thing with you. I see where it's confused.
You good?
Yeah, just talking to it.
No worries, 3 points. So now I have this, 1/2. My limits are values of u. I have u to the 1/2. And I have x squared dx. The red box is 1/3 du. So that's a multiplying constant. And as I heard someone say, the transformation is now complete. Sounds like a line from a movie. So now I can start the problem from the beginning. Like I can ignore everything I've done to this point, start as though I have a brand new problem. But it's a much simpler problem because I've done the U transformation. Question? No? Very good. So copy this page over, 1/6, integral from 1 to 9. Now here's where we start. 1/6. You're going to go from 1 to 9. U to the 1/2 du. So I still think of this as being f prime. So I find the antiderivative, which would be u to the 1/2 plus 1 divided by the same, evaluated from 1 to 9. So no more integral sign. I've gone from integrating f prime to evaluating f. Now it's a matter of just plugging the numbers in. So I'm going to keep going so the video has finishes the problem. Good job today. Dividing by, that's 3/2. Dividing by 3/2 is the same as multiplying by 2/3. This would be u to the 3/2 power. In case you've forgotten, 3/2 power means we must cube and square root. So as you're packing up, just keep listening. So this becomes 2 over 18 or 1/9. That can factor out. I'm going to have 9 to the 3/2 power. Subtract 1 to the 3/2. Again, the 3/2 indicates a cube and a root. So I'd rather do the root first. So the square root of 9 is 3. 3 cubed is 27. So this becomes 1/9. 27 subtract 1. So that becomes 26 over 9. Question? Good job, you guys. Good work. If you want to do your homework here, because this can get, I don't know, it's easy to make a mistake, you're more than welcome to come after school and just work here and just ask me whenever you need help.
Mr. Smith, this is the square root of 1 just 1, so it'd be 1 times 3.
Oh, square root of 1 is 1, then it's 1 cubed.
Oh, it's 1 cubed.
Does that make sense? Yeah. Oh, sure. Some of the seats are decent on the back.
White.